So let's see what are the contents for today. So we're gonna start about we're gonna touch the basics of machine learning, then start off with the applications of random forest and different types of algorithms or ML. What is the main and primary difference between classification and regression? Like what is actually random forest? Why do we choose random forest over many algorithms and decision tree algorithms? Like then the difference between decision tree and random forest, and lastly a code to supply with and a case study. So basically jumping right into it, like what is artificial intelligence? Like if you break the bubble into two, so there is machine learning and deep learning. So artificial intelligence is something a program can sense, reason, act or adapt to something. It can be robot, it can be anything. It's starting from anything. If we train a machine like that, it starts from anything like that. So jumping right into like machine learning, like algorithm, machine learning are a set of algorithms whose performance improve as they are exposed to more data over time. Like it improves over time, like with experience and like proper training, it improves over time. Another subset of machine learning is deep learning, which is a multi-layered neural networks where the data or the machine learns from vast amount of data. It's like a imitation of human brain, of how it like how our human brain functions utilizing the neurons in the neural network. So what is actually machine learning? So machine learning is a study of algorithms which gradually improves over time through regular learning and experience. Like so basically it can be called as a subset of artificial intelligence. So it has a variety of applications, like starting from email spam classification to object detection, as well as natural language understanding sentiments. So we see in today's world there is a like huge application of like machine learning, from starting from financial sector to robotics to news, everything, everywhere there is machine learning right now, and it's kind of a buzzword right now in the current world. Jumping into it, like what are the types of machine learning algorithms? So broadly, machine learning algorithms can be classified into supervised learning, unsupervised learning, as well as reinforcement learning. So another semi-supervised learning research is going on. It's very high level, and its research is going on in Facebook under Jan LeCour, and that is not well articulated till now. Broadly, we have three learning algorithms right now. First of all, like supervised learning. In supervised learning, what we do is like we train our machine with the data which are already tagged or labeled correctly, because the labels are already provided and the data is already instructed in terms of it. So basically we tell our model to learn on the basis of the facts which are already provided, so that when the new set of data are provided, you can actually predict in terms of that and check the accuracy along with it. So this is how the supervised learning works. Like once the machine is trained, now new examples are provided to analyze the already trained data and produces a correct form of labeled data. Then we can, there are like evaluation metrics, then we can check accuracy, F1 score and stuff like that. So coming on to unsupervised learning. So in unsupervised learning, the data is not labeled actually. So say for example, like when you were in school, if you take the mask, like your marks of every subject, it is not labeled because nothing is labeled at the in the target column. So in unsupervised learning, what we do is like we find the hidden patterns within a data. Like we clustered the data, like this group of section students are very good, this section of students are like below average, stuff like that. People like 10 people have scored about 90% in like maths, 10 people have like below 60 in chemistry and stuff like that. So what we do is in unsupervised learning, we tend to find the like hidden patterns within our data. So coming back to reinforcement learning, so reinforcement learning is very different from this too, like what I told about supervised learning and unsupervised learning. So reinforcement learning is the area of machine learning where agents are trained to take actions in an environment and get rewarded each time to maximize the cumulative reward. So in basic word, it means that there is an agent and for each decision, each right decision it takes, it gets rewarded on the way. So basically we kind of automate the process, like in getting rewards and rewards, the agent quickly learns like where it will get reward, where it will not get rewarded. If the agent gets rewarded, it automates the process in that way. So we reinforce the algorithm or the data which comes in. So reinforcement learning is like not very product, it's not very used in production right now. It's still in the developing phase as well. Like companies like Google DeepMind, OpenAI, they are working on the reinforcement learning part. And still widely used in the industry are the unsupervised learning and the supervised learning algorithms. So today we'll talk about random forest. So random forest comes under supervised learning. So supervised learning can be broadly classified into like broadly divided into two methods, like regression and classification. So regression is approximating a mapping function f from input variables x to continuous output variable. So in basic words, so in easy words, what we can say that regression is like predicting any continuous values in the target column. So which means like quantities such as amounts, sizes like 1.001, prediction of house prices, assessing risk in financial services or insurance domain. So it's basically like predicting the continuous like output variable in the target column. So that can be called as regression. So in classification is approximating a mapping function f from input variables x to discrete output variable y. So in the classification, so basically what classification means is like a Boolean value, like yes or no, 1 or 0. Like we do not take any continuous values here, we take discrete output, like discrete values here, like 1 or 0, true and false. Like it can be classes, like it can be classes, it can be 5 classes, 6 classes, 10 classes, but it's not a like numerical decimal figure compared to regression. So that is classification. So classification is used for like to know whether a patient has a cancer or not, a person is a loan defaulter or not, because these answers are like generally yes or no, apart nothing like that, like nothing 1.001, 1.002, you, because those come under regression, like email is spam or not, plus yes or no basic. So regression and classification is done. So jumping right into random forest. So what is random forest? So random forest is a type of supervised learning algorithm which can be used both for classification as well as for regression tasks. But mainly random forest, what we use random forest is for like classification tasks. So as the name suggests, you can see that it's a forest which is a collection of trees. Same like in the random forest algorithm, multiple decision trees are created during training the sample data, and at the end we take the best result from it by taking the mode of it. So I'll make you understand what is random forest. So previously people were working on decision tree, where we take one tree to classify the entire data. It turns out that it's not highly accurate, or the things which we need to know is not like coming very accurately. So people came out with this thing called random forest, where we build multiple trees, and from each tree we take out the result, we get the result, we obtain the result from each tree, and then we take a mode of it. Mode means we do a voting of it, and the maximum thing like mean median mode, we take the mode, the maximum vote we take the mode, and that is our prediction. So random forest algorithm combines the output of multiple decision trees to generate the final output. So as the name suggests, random forest, it implies that it consists of a large number of individual decision trees that operate as an ensemble. Each individual tree in the random forest spits out class prediction, and the class with most votes becomes our model's prediction. So it behaves as an ensemble like algorithm as well. So let us see some of the applications of random forest. So in classification of loan defaulters in banks, so the financial sector till object detection, it can be used for object detection like pose estimation and for classification. So as of now, like random forest has a huge application in computer vision, as well as like every other sectors, like everywhere there is random forest used right now, because of its high accuracy, and it outperforms many other algorithms which are the state of the art algorithms. So coming back to ensemble algorithm, as I told ensemble algorithm earlier, ensemble algorithms are those which combines more than one or more similar different kinds of algorithms for the desired output. So random forest is an ensemble tree based learning algorithm. So here, as we can see, that there is tree 1, tree 2 and tree 3. So here what we do is, like, we break the instances into 3 and into different classes. So class A, class B and another class B. And what we do is, like, these are like random features within an algorithm. So what does random features mean? So it's another concept of like feature randomness, like in a normal decision tree, when it is time to split a node, because each tree has a node, and we consider every possible feature and pick the one that produces the most separation between the observations in the left node and the right node. Okay, so in contrast to that, like each tree in random forest can pick only a random subset of features. Like we are not picking individual trees, like we are picking a random subset of features, because this forces even more variation amongst the trees in the model. So basically what we want is that we don't want similar trees. Like in random forest, what we like when we are constructing like a forest of trees, like we don't want every tree to look alike or to have the same features. So basically, so in terms of like statistics, it's known as like correlation. We want it's better to have low correlation between the trees. So low correlation means like low variation, like more variance. Like this forces even more variation amongst the trees in the model, and ultimately result in lower correlation across trees and across diversification. So another concept, like bagging, like decision trees are very sensitive to the data they are trained on. Okay, so small changes to the training set can result in significantly different tree structures. So if we tweak one single features in a single decision tree, the result changes a lot, so which can overall hamper our like outcome or prediction or accuracy maybe. So in random forest, so what does random forest do? In that case, random forest takes advantage of this by allowing each individual tree to random sampling from the dataset with replacement, resulting in different trees. So what we do, we randomly select some of the features from the data and put in each tree. So which makes the tree more variation compared to others. So this process is known as bagging. Okay, this process is known as bagging. So bagging means bootstrapped aggregation. So let us see, like, how does random forest actually work? So selection of random samples from a given data set. First thing we do, like we select set of random samples from a like given data set, the data which are already provided. So for each and every sample, the algorithm will construct a decision tree. Supposedly we make 5 clusters, like 5 random samples in our data, and for each sample the algorithm will construct a single decision tree. Whereas on the other hand, if we compare it to the decision tree algorithm, this is decision tree makes one tree at a time, only one tree for the entire data. But over here, for we are breaking up the data into 5 or 6 parts. For example, I'm saying like 5 parts, and from 5 each decision tree is like constructed to ensure like high variance is there. So from the above decision tree, it will get all the predictions. So from the 5 decision tree which we constructed, now we do a voting. Like we'll do a voting of the every predicted result obtained from the like previous step. Like we take a mode of it, like which prediction won over the others, which has the highest prediction, and lastly we pick the most voted result to be our final result. So here you can see I've provided a diagram as well. Like this is the whole training set consists of the whole data set, like whole data set which is provided to us. Then we are breaking up into like training sample 1, training sample 2 until training sample n. So this we can control. This is within our hands, the number of trees which we want to construct. And from this training sample we are taking the random sampling thing, and we are doing a subsequent voting here. We are doing a subsequent voting here to get our result, to get our like prediction from the like training set which was predicted. So I will come back to this, like what is a test set, and I will come back to this. So basically, so let's talk about the advantages of random forest. Why do we use random forest? Like overfitting is reduced by combining the results of different decision trees. So overfitting is a concept. So as we were talking about the advantages of random forest, so overfitting is reduced since we are constructing multiple like decision trees, not a single decision tree. So basically, if I define what like overfitting is, like overfitting is a like modeling error that occurs when a function is too closely fit, because we do not want the like function to fit in that closely to the limited set of data points. Because when we provide a new set of data, so it will generally overfit, because it will not fit those data points, because it was earlier like tightly fit into those data points. So when we are constructing, when we are writing our models, we need to keep in our mind the overfitting of our model. Secondly, we come into like it has less variance than single decision tree. Since we are constructing multiple decision tree, the variance lessens. The models are like, so random forest models are like highly robust, flexible, and has a higher accuracy like compared to many classification models. But every time you do not yield like higher accuracy, like it depends on the data as well. It's random forest, it's also good in missing values. So when you step into the real world, the data which you will get is kind of a messy, dirty data in which there will be multiple values missing and stuff like that. So what random forest does is like random forest has a nice imputer as well, and it can handle all the missing values as well. So it generally works on a large amount of data, like compared to like decision tree, like where the decision tree fails to an extent because or yields low accuracy. The advantage of random forest in that perspective is that it works better on a large amount of data. So let's talk about the disadvantages of like random forest. Like it's a very complex algorithm, and it's tough to explain what is happening on the back end of it, because it's kind of a, what we say in like data science terms is, it's a like black box algorithm, because we do not know what is happening in the background, because which random sampling it's taking, why. It's tough to explain. Basically, it's more tough and time consuming than the decision trees, since decision trees like construct only one tree at a time. So it's more faster and more fast than like random forest. Whereas random forest, in terms of like constructing multiple trees, it takes more time, and obviously more like computation power is required to run it. Obviously more RAM, graphics card, GPU, TPU is required to run random forest, like whereas compared to like decision tree can be run very easily compared to. So I've prepared like hands-on code sessions for you as well. Like it's not actually hands-on because I have like screenshotted every. So what we do is like we import. So this is a like you can do it in a like Google Colab, Google Colab website, web browser, or from like if you install Jupyter notebooks as well, that you can practice this thing out. So first of all, these are the libraries like pandas, numpy. So what pandas does is like pandas is a like data frame that with the entire data which we are taking into account, which is being provided to us. So it accepts, like it's a fast, powerful, and flexible, easy tool. Like it's a kind of a like open source data analysis and manipulation tool, and it has some built-in data structure to make our like data handle easy. Then numpy, so we are importing pandas as np. Then numpy is used for mathematics, numerical, python, which can be used as for mathematics and stuff, to calculating stuffs like that. Matplotlib. So Matplotlib gives you all the visualizations of what we do. So from sklearn, sklearn is a scikit-learn. Scikit-learn is a package which consists of all the algorithms, starting from all the machine learning algorithms, starting from like linear regression, logistic regression, everything you can call up from sklearn. And sklearn consists of the matrix as well, the matrix which we will define. Metrics are defining the accuracy, F1 score, sensitivity, stuff like that. So coming back to the sklearn thing, sklearn. So another sklearn package, another model is like model selection, where we train and test split. So I will explain this train and test split. So the given data set, which is the data set which is provided to us, like, so we need to break it into two steps, like two sets of data, like train data and test data. So train data is for training training our machine on the data which is being provided, and testing the data, and we test on the rest part of the data. Like it can be like divided into 70-30, 80-20 and stuff like that. Like 70 you will use for like training of the data, and 20 for testing of the data. Or like simultaneously you can adjust to it, like it's very adjustable on that part. So importing data set, like importing data set. So as we see that pandas dot read underscore csv, and name of the csv file which is already provided, dataset.csv, df.head. So df.head, what it does is it gives out the like first 5 columns of the data set, first 5 rows of the data set, rows and columns of the data set, and you can actually view the data set what it's like we can see there is loan id, gender, married, dependents, education, self-employed, applicant income, co-applicant income, loan amount, era, credit history, property area, and loan status. So before jumping into everything, we need to pre-process this given data, because this looks pretty dirty and we need to make it clean. So the first step what we do is like in terms of like level encoding. So our computer or machine or model doesn't interpret numbers, numerical values and stuff like that, stuff as you can see, stuff like that, because gender it cannot take as like male and female. So we need to encode it with 1 or 0, like male or female as 1 or 0, or if someone is married or not as 1 and 0, graduate or not 1 and 0. So we are label encoding those rows as 1 or 0 instead of like married, gender and education. And same as like when we go to the property area column is like semi-urban. We are coining semi-urban as 1, urban as 2, and rural as 3. And if the employer is self-employed or not, we are coining it as like 1 or 2. And same as loan status as well. Loan status, we are like encoding it as like y as 1 and n as no. So once the label encoding part is done, so label, and as I already said that label encoding is one of the most important thing, and like when we are doing a classification thing, because we need to encode the words into 1 or 0, the classes which are provided like gender, male, female, into 1 or 0. So it makes the model more robust, and the result it will yield will be more accurate. So coming back to the next thing, so we need to check each and every column where the values are missing, stuff like that. So as we can see that there are many NaN values here. In the node loan amount, you can see a NaN value stuff, and gradually as we go down this data set, there are many null values which are already there. So what we do is like we need to put some values, because our algorithm doesn't take, any machine learning algorithm doesn't accept like null fields or null values. So what we do is like we do a null value imputation. Imputation means like impute those null values with some values. So not by any random values, but we do it on the mode of the column. So here we are doing the imputation on taking like mean, median, mode, and we are taking the mode of it. The maximum, suppose there are like 20 gender, there are 20 male and 10 females. So if there is a blank there, we are taking it the male there, providing it with male. We are taking the maximum value or maximum prediction. So all the columns needed like null value imputation, because there were missing values in gender, married. These are like column names: gender, married, dependents. self-employed, credit history, loan amount, and loan amount term. So there were missing values over here, and we are replacing it with the mode of that given column. So now we get kind of a clean data set where it's null, where it's like mode imputed and as well as like label encoded. The entire data set is now is like cleaned and can be fed into our classifier. So now, as I have already spoken, that we need to divide our like data set into 80-20 ratio for training and test respectively. So here we can see that there are columns which are, so we need to feed two values into the x and y. So we are predicting x and y, right? So in x we are dropping columns loan id and loan status, and y we are only like putting loan status. What we are doing, that we are splitting the entire data set like x train, x test, y train, y test. And this is the name of the function which we already like here we have already like mentioned here. We are just calling that function. Then x and y, then test size is means that size of the test set, so which is 0.2, and our training set is 0.8. So let's look at the shape of our thing. Like we are printing the shape of like x train, x test, y train, y test. It comprises of like 491 columns, like 491 rows and 11 columns, and with x test as 123 11. In y we are predicting, since y do not have any row values because we need to like predict it. These two are blank because we need to predict it. So first I will compare two models, like decision tree model and a random forest model. So we are building decision tree model at first. Like we, from, as I have already told, like from Skill-Learn there are already like classifiers already provided and set of algorithms. So we call our classifier here, and we base the criteria on which we will want to classify it, like entropy. Then we are fitting the decision tree into our x train and y train. So once it's fit, the algorithm starts to train on itself, seeing each value and how it can classify each thing. Then we can predict it. Then we are predicting the train into the train thing. So let's see the F1 score of this one, like on the training set. So if our training set gets trained well, the F1 score should be always 1, because it's already training on the same set of data which the machine has already seen. Now when we are taking those set of like values, those set of like hypothesis to the next thing, the next testing set, like the rest 20% of it, there we can see the F1 score falls to 0.79. So keep in mind, like the testing set evaluation is the main criteria over here when we are evaluating on something. So it's 0.79 here. Jumping into random forest right now. So we are building the same classifier as like decision tree, because we are importing it from sklearn, and it's basically same the way. Once you have completed with your like cleaning, the main part lies in cleaning of the data, arranging it and stuff like that. So once the data is clean and ready to fit into a model, it hardly takes like 5 or 10 minutes to fit into the model. So from sklearn ensemble, we are like importing like random forest classifier and evaluating, like we're building this first set of 4 lines is for building the random forest classifier. Then we are evaluating on training set, the 80% of the set which was already there. So as I've already told, the training part obviously obtains like F1 score of 1.0, and now we test on the rest 20 part. So previously in decision tree, what we got is like 0.79 of F1 score. And now in the testing set evaluation, we are getting like 0.846. So which is like significantly better than a like decision tree model. So random forest. So as you can all see that it clearly outperforms the like decision tree model. It yielded like 0.79 there, but it's 0.84 over here. So let's talk about another important thing, like feature importance. Since in decision tree the features are not given, the features are randomly decided, because we are constructing only one decision tree, and we cannot take our judgment and our like judgment on the basis of one decision tree. So here you can see that decision tree, the green ones is the decision tree and the purple ones is the like random forest. So green ones so like unknowingly gives high accuracy to like high importance to credit history, applicant income, loan amount, whereas compared to like random forest, so since we are constructing multiple decision trees there, and it's like its reasoning significantly improves, and our algorithm or model knows which feature to give more importance to get more accuracy. So as we can see, like we can plot this thing using matplotlib firstly, and we can see that loan amount, like compared to decision tree, random forest makes a better decision. So since random forest combines multiple decision trees, it becomes difficult to interpret but not completely impossible to interpret. So it can be black box, but it can be explainable to an like extent. Like as well as random forest has a higher training time, like when you are training on your own these models. So when you train a decision tree model and a random forest model, so decision tree will take significantly less amount of time compared to the random forest, because since random forest is obviously constructing multiple decision trees and it's a very complex algorithm. So please take into account your limited time when increasing the number of trees for better classification. So as you can see that we can increase our trees significantly to get higher amount of accuracy, but that's not the case every time. So the accuracy will go and like stuck at some part of like the percentage, and then you can't get anything better even by increasing the number of trees. So when you are increasing the number of trees, just take your time, just see your time and do within your limited time. But nonetheless, random forests are great to achieve more accuracy, and anyone with people little or no knowledge can use tree based algorithms to make quick data driven decisions like in their company. Like you do not want like or have much knowledge about statistics, but you can do a significant good prediction analysis using random forest by writing a few lines of code, and that's it.